Good morning. Welcome to online teaching education system of R.P.M. Lovely Public Senior Secondary School, New Lalpur. Today we will be going to discuss class 10th, chapter 12, electricity. Topic Ohm's law and the factors affecting resistance. In this we will cover Ohm's law, what is resistance, and the factors on which resistance depends. We will derive the expression for resistance and understand the difference between resistivity and resistance. So let's understand about Ohm's law. As in previous class, we have understood what is potential difference and electric current. So today in Ohm's law, we will be going to discuss about the relation between potential difference and electric current. Ohm's law states that the potential difference between 2 points is directly proportional to the electric current at constant temperature. This means that V is directly proportional to I. If potential difference will increase, current will increase and vice versa. If we will remove the proportionality sign, we will get V is equal to IR, where R is the constant of proportionality. And I, if we want to derive I, value of I, then we can say that I is equal to V by R. Or if we want to know the value of R, the resistance, then the formula will be V upon I. So R is a constant for a given conductor at given temperature and it is called the resistance. So let's understand now what is resistance. Resistance is the property of the conductor which resists the flow of electric current through it. The SI unit of resistance is ohm. Ohm is denoted by Greek letter ohm, and 1 ohm is defined as the resistance when 1 ampere of current is flowing through a conductor having a potential difference of 1 volt. That means 1 ohm is equal to 1 V upon 1 A. So we can say that if current will decrease, the resistance will increase, and if current will increase, the resistance will decrease. Here is the potential difference and current graph for Ohm's law, which is a straight line because both are directly proportional to each other. And this is a circuit diagram for Ohm's law in which the voltmeter is always applied in parallel to the resistance to calculate the potential difference, and ammeter is always applied in series to the circuit to calculate the current. So let's understand that what are the factors on which resistance depends. So resistance depend, number one, on the length of the conductor. So we can say that if the length will increase, the resistance will increase. If the length of the conductor decreases, the resistance will decrease. So we can also understand this in a way that if we will double the length of the conductor, the resistance will also get doubled. If we will reduce the length of the conductor to half, then the resistance will also become half. Next, it also depends on the nature of the conductor, whether the conductor is made up of copper, aluminium, silver. So, it depends on the nature of the conductor. It is also directly proportional to the temperature of the conductor. If there is increase in temperature, the resistance will increase, and if there is decrease in temperature, the resistance will decrease. Resistance is inversely proportional to the cross-sectional area of conductor. Area of conductor here means the thickness of the wire, and when we are talking area is equal to pi r square. So r is the radius of, so we can say that if radius of the conductor will be more or wire is thick, then the area of the conductor will be more, and if area is more, then the resistance will be less because they are inversely proportional. So we can say that thick wire will have less resistance as compared to thin wire. So let's derive the resistance expression, that how we can derive the expression for resistance. From the previous slide we can say that number 1, R is directly proportional to L and R is inversely proportional to area, that is A. So from equation 1 and 2, if we will remove the proportionality sign, we can get that R is equal to rho L by A, where rho is called as the constant of proportionality and it is also called as electrical resistivity of the material of conductor. So rho is equal to R, that is resistance, into area divided by length of the conductor. SI unit of this electrical resistivity is hence ohm meter. So let's understand what is resistivity and what is the difference between resistance and resistivity. So electrical resistance offered by a substance of unit length and unit cross-sectional area is called resistivity. That is rho, which is equal to R into A by L, where R is the resistance, A is the area and L is the length of the conductor. Now the basic difference between resistance and resistivity is, resistance is the property of the conductor which is opposing the flow of the current, whereas resistivity of a conductor is the resistance of the conductor of unit length having a unit area. The SI unit of resistance is ohm, whereas SI unit of resistivity is ohm meter. So we can also say that resistance of a conductor is depending on the length and area of cross section, whereas resistivity does not depend on the length of the conductor and area of the cross section. But resistivity depends on the nature of the conductor and temperature. Different conductors will have different resistivity, and on the basis of this we have categorized different material as conductors, alloys and insulators. So conductors generally, from this table we can see that conductors generally have low resistivity and hence they allow the current to pass through them, whereas insulators, they are having the highest resistivity and therefore they do not allow the current to pass through them. And alloys, the resistivity value lies between the conductor and insulators and therefore alloys are generally used in the heating appliances. So with this we are able to understand Ohm's law, the resistance, the difference of resistance and resistivity. I hope all of you have understood the basic concept of Ohm's law, because these we will be going to use in the numerical for next class. Till then, have a safe and happy learning. Thank you.